Looking for everybody to week 6 day 2. I'm going to go ahead and start the grading of the homework assignment now. So if you're still working on it, you should probably you'll probably need to save real fast. The main frame, all right, is now being graded, so make sure you don't have it open. See how you guys do on that, and then I'm going to show you how to go about solving homework assignments like this. It's really important to understand that when you do Zybooks and you do these like small problems, it's possible to just kind of like write them and solve them and get them right, and that's good because it teaches you programming and it gives you the repetition you need to learn something. The downside is if you never work on like a bigger homework assignment like this one, which requires maybe a triply nested for loop, and inside of that, there's another for loop maybe, and is that it teaches you, especially if you only write small programs, it teaches you to just try to write everything at once and then test it and debug it and see how it goes. And that's not a viable strategy for bigger programs. For bigger programs, you have to learn to work on a little bit at a time and test a little bit at a time and then build on that success. And there's a couple issues with that. First is if you're given a giant assignment, like make World of Warcraft from scratch. How do you even go about decomposing that? How do you break that into different problems that you can solve, right? And that's something that takes years of experience, right? For like, I don't think I'm qualified to just on a notepad sketch out like how I would make World of Warcraft from scratch. That's a giant thing to do. Write Microsoft Windows from scratch. Yeah. Let alone not being able to do it. Just even how to just break it down into like, this team needs to work on this part and this team needs to work on this part. I wouldn't even know where to begin, right? It's just too big, right? Even for my brain. So what you need to do is start small. And this is like a slightly bigger problem. Hack the mainframe is slightly bigger than maybe what you're used to. And what you'll find is that the more you program, your brain will start kind of like growing and it'll stretch and it's uncomfortable. And you have to like think about things and it hurts sometimes. And you need to start early, which is another thing. Like my Discord messages were blowing up last night, and it's unfortunate because I was tired. I went to sleep at 10, and I was getting messages from people at 1 o'clock in the morning, and nope, I had my phone on snooze. So it's not like I was doing that deliberately to like fail students or whatever. It's just I was tired. And so you need to start early enough so that if you get stuck on something, you have time to get unstuck. And that's an important life lesson right there as well. So I'm gonna go through how I would do hack the mainframe. So let me become Alice. Just as a dummy account that I have. Do I not have? Okay, maybe I didn't deploy it. Vim test. I've only got Rob Thomas and Banksy. Okay. Let me become Banksy. Okay, so let's do this from scratch. Okay, so one good advice for y'all is to have two different Vim README is to have two different screens open, split screen mode, or if you have two monitors, you can put the README and code on a different monitor, so you can kind of look at it while you're going through it. So for this assignment, I actually did the decomposition for you. I broke it into different parts for you. I gave you a die function, I gave you a make secret, but then here in main, you can see I broke it into part 1, do this, part 2, do this, part 3, do this, part 4, do this. Which I did because you're only on week 6 of your programming career, and for most of you that are computer science majors, your programming career is going to be a long and illustrious one. You're only in week 6 right now, though. And so a lot of times the hardest part is actually how do you break it down, and I kind of did it for you. For those of you that are not computer science majors, which is fine, it's nothing wrong with not being a computer science major. It's A-okay. Your computer science career is also probably going to be long and what? Huh? What? If you're a math major, you're only required to take 1 semester of math. Guess what? One of my former students, who was a TA for this class a couple years ago, is finishing up a math degree at Fresno State right now. Her math class right now is all programming. It's not, she's like, there's no math in it, it's just programming. You know, because when you get into the higher levels of math, guess what? Surprise, you got to program again. And so it's really important to pay attention now. And I would recommend taking both 40 and 41 at a minimum if you're a math major or a physics major. Physics majors only have to take 1 semester of computer science. Guess what? Guess what high level physics is? It's a hell of a lot of simulations and math and programming. So if you're a physics major, I'd also recommend taking more computer science. Okay, so we'll just take this one part at a time. Ask how many digits the secret code is. Now let's just look over here at vim.vimrc. We got mouse mode on. Get that out of here. No mouse mode for me. Vim readme. Okay. Good. All right. So the funny thing is, I have to quit. Come back in, and good. Mouse mode is off now. Okay. Is that mouse mode actually makes it harder for you to use the mouse to copy and paste things. So how many digits long is your secret passcode? With mouse mode off, it's really easy to just do this. You just select it. When you select it, it copies it. So ask how many digits. Okay, well, that sounds like to me like a cout statement. Boom. There you go. Done. And then we have to vet input. Okay, so int digits equals 0, cn into digits, and then vet the input. So the input, okay, they could type in squirrel. So if they type in squirrel, or if they type in digits less than 1, so if they type in a number less than 1, or they type in, you might notice I'm using, I'll be consistent here. Just use the words for each. Or digits is greater than 6, then guess I'll die now. So that's how you vet the input, 1 line. Some people do this on multiple if statements, that's fine. But you don't need to. If either they typed in squirrel, or they typed in a number less than 1, or they typed in a number greater than 6, then die. Hold on, how did you paste from the clipboard into Vim? Shift insert. So if you are in insert mode, you hit shift insert, it pastes. Or you can right click. If you're in insert mode, right click does the same thing. Yep, very useful stuff. I would turn off mouse mode on you, and you can turn off mouse mode by editing your vimrc file from your root directory. And the second line there turns on mouse mode. I hate mouse mode, but students ask for it to be on, so whatever. Mouse is a trap. It slows you down. Keyboard's all you need. Okay, so anyway. So that is part 1, done. Part 2, read in a seed and seed the random number generator with it. Okay, sounds pretty similar to this. Y for Y, and then paste. And rather than how many digits long, I go to the rock band drums. I don't. That's funny. Please enter the random number seed. So right click and new line. There we go. And rather than digits, we're going to call this seed. So digits is 6 letters long. 6 letters long, right? So I type 6s. That deletes the 6 letters and puts me into substitute mode or insert mode. And I'm going to type in seed here, hit escape. Now in Vim, there is the ability to replay the last command you did. So I'm going to come over here and hit dot. Dot replays the last command. And so if you want to replace digits with seed all over the place, you just go over to them and hit dot. Simple search and replace. I don't actually like using global search and replace, because then, you know, digits up here would change into seed, you know, and stuff like that. So I tend to change it manually like that, and then I search for digits and tap N to go to the next one, and hit dot to change it if it should not be changed. Okay. So I kind of manually do my search and replace. I've been burned too many times by my global search and replace changing some comment or changing a variable that I didn't want changed. So I very rarely do global search and replace. I like to look at each one. Okay, so S stands for substitute in Vim. And we actually don't care if seed is negative or positive, so that's good. All right, so now we are going to seed the random number generator. We talked about that last time. The random number generator in C++ is not random. It is not random at all. It is in fact deterministic, but it appears to be random. And the way that you make it more random, I guess, is you seed the random number generator with a number. And then that initializes the internal state. There's all these gears and parts inside of the random number generator. It initializes it to a certain state. It sets the internal values to a certain value. And then when it starts producing random numbers, it'll always give you the same random numbers every time with that seed. So to be really random, you do time, you pass in the current time. That's actually not really random. That's like medium random. It's still not very secure. Don't use srand or rand in any sort of serious application. Okay. You can specify the lines you want changed, 5 to 12, search, foobar, global. Yeah, you can. And it's probably, I don't know. I just really like looking at each thing before I change it. I feel very nervous doing broad search and replaces. Okay. So that seeds it. And so the reason why we do this is so that the auto grader will work. If you pass in the same seed, you get the same random number every time, and I can auto grade your code and make sure it works right. I just throw a C so it confirms on each change. Yeah, you can do that. Definitely. Okay, so seed. Okay, so that's good. Okay, generate the secret code of digits long. Okay, I've got a function for that. It's called make secret. So make secret takes in the number of digits and it makes a secret of that size. Okay. So string secret is equal to make secret pass in digits. So that'll generate our random secret pass, or a secret number. So everybody guessing for? And then we're going to get to the good stuff. So first of all, let me verify this, and I probably should have mentioned this before, but as I went along, I should be doing this, and this, and this. So when you're writing your code, you need to test your code. Like, don't just assume that it works, especially when you're a CSI 40 student. So how many digits long? -10, die. How many digits long? Squirrel, die. How many digits long? 1. Okay, accepted. How many digits long? 7, die. How many digits long? 6, cool. Random seed, cool. And it made a secret code. So in the README file, it's got it tells you what the secret code is for a couple of the different sample runs. And so I'm just going to verify that it matches. So for this one, it is 2 digits long, and the random number seed is 1 in this case. And so it's giving me 83 as the nuclear launch code. So that is correct. And then if I scroll down here, there's another sample run here. So that one has 5 digits, and the seed is 42. So this is giving me a secret passcode of 76166. Cool. And if I wasn't getting this, then I would stop here and try and figure out what was wrong. You need to always be C-outing all the things. Okay? It's the most common mistake. Like I was getting like PMs all last night, and people were sending me copies of their source code, and they're like, "What's wrong with it?" And very few of them had C-out statements in there saying like, "Okay, I'm here, I'm here, I'm here." And so if it doesn't work, and you've got this giant block of code, I guess all you can do is just mail the professor for help, but that's not a very robust way, because one of the skills you need to learn in computer science is tracking down where your mistakes are. Where is the bug? What's the problem? And if you don't see out anything, how are you going to know? I mean, if you know what a debugger is, you could use a debugger. There's nothing wrong with that, but most of you don't. And so you need to get in the habit of just see-outing everything. everything. And just verifying, testing, you know. I tested this with squirrel, and with 1, and with 3, and with 10, and with -100, and +100, and 6, and 7. So everywhere there's an edge. 6, I try 6, I try 7, try 5, try 0, try 1, try 2, squirrel. Test these things thoroughly. Okay. And then after I'm happy, I take out the cout statements. Or if you want, you can comment them out if you want. Or if you want to be really super elite, you can use cerr instead. Cerr is just like cout, except the autograder doesn't read it. So if you're afraid of failing an autograder test case because you're outputting some debug information, well, just cerr it instead. And if it stays in there at the end of the day, well, it's fine. The autograder ignores it. So cerr is like cout, but is ignored by the autograder. So if you have any debugging information to print out, you can do it that way. But you should get into that habit of couting everything. And that's something I have to just keep harping on. Even with my CSci26 students, they're sending me all this code, and they're like, why doesn't it work? And I'm like, well, what have you tried? You know, where is it going wrong? I don't know. You know, like right now, I just had a student send me, let's see if I can strip the name off of it so I don't embarrass him. This is in CSci26. This is not 40. Okay, there we go. So it's in Notepad. So he's like, what's wrong with this code? I don't know, dude. It's like 4 pages of text, you know? It's a lot of text, man. I couldn't figure out what to do. What do I have to change to make this code compile? Yeah, so yeah, you know, and usually my answer is not because I'm lazy, but like, what have you tried to do? Where is it going wrong? Why is it wrong? What can you identify which part of your code is breaking? And if students can't answer that, that means they haven't tried couting, you know, whatever loop they're working on or something. Why is my code going into infinite loop? I don't know. Why is it? You know, try couting the stuff, printing out the values, and seeing what the value of everything is when they go into an infinite loop. That's just good practice right there, you know? So that's a lot to try to understand in 5 minutes. What is couting? I don't know. Just, that's the habit I want you to get into. Okay, so the code they sent you, yeah, make it work. Like, I don't know. Yeah, I mean, I could, but it's like, you know, it's a big wall of text, you know, to look at. Okay, so now we're going to get to the meat of it. Okay, so now we're going to go into the main loop. All right, and so we're going to have a triply nested for loop. 20 times, we're going to read in a passcode, a guess from the user. For every letter in the guess, we are going to see if that letter is within the secret. Okay, if it's not within the secret at all, then it's wrong. If it's in the secret and in the right place, it's correct. If it's in the secret but in the wrong place, that's a near miss, or a kinda, or however you want to put it. Okay. So you can start either way. You can start with the outermost loop and work your way in, or you can start with the innermost loop and work your way out. To me, starting with the innermost and working your way out is the correct way of doing it. At least for this one, I think it's the right way of doing it. I wouldn't say correct, but it's what I would recommend. So what is the innermost loop? The innermost loop is just finding out if a character is in the string. Okay. There is a standard library function for this, by the way. You can just call find, string find, which I know some of you were using on Zybooks. You could use that. But I'm just going to write it from scratch. I don't assume you guys know the standard library. It'd probably make your life a little easier, at least. Okay, so let's do this for ijk. Size pk equals 0. K is less than secret.size k++. So what does this mean? This means k is going to go from 0 to 1 less than the size of the string. So the size of the string is 6. It's going to go from 0 to 5. So basically for every position in the string, character 0, character 1, character 2, character 3, character 4, character 5, we're going to look to see if a certain character is in that string. And so I'm just going to use character 1. Okay. And yeah. So let's see if that character is in the string. So we get an individual character out of a string using .at. So we can say if secret .at k, that means give me the kth character from the string. So when k is 0, this gives you the first letter from the string. If k is 1, it gives you the second letter. Okay. If that letter matches 1, then we need to do something. And so right now, all I care about is if it's in the string at all. So what I'm going to do is make a Boolean like I did last time called matched set equal to false. And if we ever discover it in the string, I will set matched equal to true. And that is that. It's not doing an exact match. It's just saying if it's anywhere within the string. Okay. So after we do that, we're going to see out all the things. If matched, else. Okay. So if we match it, then we're going to see out C was in the string secret. Otherwise, C was not in the string. And that's it. So we start off with a little one-line for loop, really. It's just one. I don't even need the curly braces. Just one line. So starting at the beginning, going to the end of the string, if that character is in the string, then return true. Or set matched to be true. Then after the loop is over, we're going to print out it was in the string. One mistake a lot of students made, by the way, was they did this. They stuck it inside of the for loop, like that. They did this. And so for every character within the string, it'll say if it was in the string or not. So it's going to print out 6 times, over and over again. It was in the string, it was in the string, it wasn't in the string, it wasn't in the string. Okay. So let me show you what it looks like if it's a bug. And this is why outing all the things is so important, because you can see immediately where your problem is, right? All we're checking is one character being in the string, and it's printing it out 6 times. Which is wrong, right? 1 was not in the string, 1 was not in the string, 1 was in the string, 1 was in the string, right? This is clearly not correct behavior. You don't want to print out 5 times that it was in the string or not in the string. You only want to conclusively say it was in the string or not in the string after you've finished searching the whole thing. So yeah, this was a very common mistake. U6D, paste, left shift 6, there we go. So after you've swept through the whole thing, if matched is true, that means it was in there somewhere. Okay. And so if we run it again, we find out that 1 was in this string here. Let's see if I can get one that's on it. So 1 was not in the string 289383, but it was in these strings. Okay, so good. We now have code that can search a string and tell us if a certain digit is in it. Okay, so next up, we need to do this for every character. For every character in the guess. So we have to do a guess. See out. That. Okay. Please enter 2 digits. It's not going to be 2. It's going to be secret.size digits. Okay, so please enter 5 digits, 6 digits, however many digits is in the passcode. We're then going to have a string called guess. We're going to see into guess. We need to vet guess, but I'm not going to do it just yet because I want to show you guys the approach. Right? In this case, vetting isn't. If we go out of bounds, if we go too far, it'll crash, but because we're using .at, it'll crash nicely. It'll print an error message. You went out of bounds. No, you're out of bounds. Okay. I was outputting the correct answer, so I had to check your code slightly to get it. Yeah. Correct in the wrong position. Wrong. Okay. So we're going to read it in a guess. Cool. So now all of this code here is going to go into a for loop. So we just wrote the innermost loop. We're now going to write the second part of the for loop. So I'm going to show you guys a trick. mx. M in Vim is a command to set a mark. These are used for bookmarks. So I can, at any point, jump to that bookmark by using single quote. If I type single quote x, it jumps down there. If I'm down here, single quote x, it jumps back up. So it's very useful. You can have, you know, a markup here. If I type mq, that's mark q. Single quote x jumps down there. Single quote q jumps up there. If you have a large source code file, and the bookmarks persist even if you quit and relaunch. If I single quote x, single quote q, it'll jump. Those bookmarks are preserved. And that's very useful. Just if you have a big 1,000-line bit of code, you could search for things like, what do I call it, secret or something, and then it turns up all these different things here. If you want to get rid of the highlighting, Bell asked about that last time. He would search for just a random string, like if you had a bunch of things highlighted. The official, unofficial way of doing it is you just search for something else and it clears the old highlighting. But I have given for you a special binding. This isn't core Vim. It's something I've done. I bound the NOH key in NOH command. So normally to turn off highlighting, you type colon NOH, like no plays in Japanese to do it. I've bound that to enter. So if you have something highlighted like that, hit enter, turns off the highlighting. You're welcome. Okay, so here we go. So I've set a mark here, and I'm gonna basically take all of this code and just indent it so the formatting looks nice. So I say right arrow, single quote x, and it indents down to the mark one block. And I'm gonna wrap all this in a for loop. So for int j equals 0, guess.size j++, and I come down here and slap the closed curly brace on it. Always get your curly braces done first before you work on anything else. Okay, so the only thing that's going to change here is rather than hard coding in 1 that we're looking for, this is just going to be guess.at_j. Okay, so the first time through the loop, guess.at_j will be the first character in our guess. If we typed in 1, 2, 3, 4, 5, the first time through the loop it's 1. Second time through the loop it'll be 2. Third time through the loop it'll be 3. And it's not an int, it's a character. So it's the letter 2 with the letter 3. Not the number 2, it's the letter 2. The ASCII code. So we're going to grab the first letter out the first time through, the second letter out the second time through, and the rest of this code stays the same. So save, run, test. Did I not do the curly braces right? Huh, I wonder what happened to that. I wonder if I deleted that by accident. Okay, so run it. So 1, 2, 3, 4, secret passcode, 6 digits, random seed of 42. Okay, so the right answer is 876166. So I'm going to type in 1, 2, 3, 4, 5, 6. And we see that 1 was in the string, 2 is not in the string, 3 is not in the string, 4 is not in the string, 5 is not in the string, 6 was in the string, and then we went out of bounds. We accessed element 6. That's not good. So j is less than guess.size, and that's why we use .at, my friends. If I was using square brackets, it would have very happily gone out of bounds and read through memory. Friends don't let friends use square brackets. Okay, so yeah, j is less than guess.size. It's hard to talk and type at the same time. So there we go. So that should fix it. And 6 digits, random seed of 42. 1, 2, 3, 4, 5, 6. So 1 is in, 6 is in, 2, 3, 4, 5 are not in. 876166. Okay. So what's our next step? And this is the next step that got you. They got most of you, I would say. Not all of you, and some of you didn't try it at all, maybe. But this next step is the hardest part for this assignment, because there's actually 3 possibilities, not 2. This part's easy. Is it in the string? Is it not in the string? But how do you get to 3? The third possibility is exact match, non-exact match, and no match. And that logic is where the gears kind of came to a stop. So, I'll show you. Just give you the answer. Right here, if you have the match, you don't know yet if that was an exact match or a near miss, right? So we need to check. So here, inside of this if statement, we have a nested if statement. So if the guess, so we're currently processing letter J, right? The first letter, the second letter, the third letter, whatever. So if the third letter or whatever of guess exactly matches the third letter in the secret, well, hooray. Exact match. Else, was a near miss. And there we go. Those are the 3 outcomes. So this thing right here, where you have to check to see if the second letter in guess is the same as the second letter in the passcode, that was the thing that I think caused various aneurysms and strokes in the class. So if we type in 6 and 42, 2, 3, 4, 5, 6, 1 was a near miss, 2 was not in, 3 was not in, 4 was not in, 5 was not in, 6 was an exact match. Okay. We run it again, 6 digits, and I type in 876166, we get exact match on all of them. Okay. So all we have to do now is just count how many of each we got, and we're in the home stretch. But do you see that approach that I took? Because the reason why I'm solving this for you is not to flex. It's something I talked about in the previous class. My math professor, after I finished college, I basically decided to take an extra math class just for the hell of it. And my math professor said, on the final, that only took me 15 minutes to solve. I made the final, I solved it myself, it took 15 minutes. I'm going to give you an hour, or maybe it was 2 hours, I don't remember now. Go. And it took me right to the last second to finish that final. I felt kind of crappy about it, you know what I mean? Because like he solved it in 15, and it took me like an hour or 2 to do it, you know. And I was working hard, like I wasn't even like, you know, just sitting there staring at the paper, you know. But then it occurred to me that when you know the answer to something, it's a lot easier to do, right? So the reason why I'm solving this for you live is not to show you how quickly I can solve the assignment. I know I made the assignment. It's easy. I made it. It's not a challenge for me. What I'm showing you, the reason why I'm going through this is I'm showing you the process by which you break down a bigger, it's not even that big, but a bigger program, and you get it, you test it, you make sure it works, and then you build on it a little bit. Get it, you test it, you make sure it works, you build on it. That way, it's like growing a pearl inside of an oyster. You start with a little seed of sand, and you wrap it in mother of pearl, and eventually you end up with a beautiful pearl. So what I'm really teaching you today is the approach towards solving a programming problem. Okay? And it's something all of you tried to do probably, so it's probably of relevant interest to you. Okay, so all that we have left to do now, we do need to vet the guess. That's why I left the to-do up there, so I don't forget. We need to track how many of each one we got. So we're going to make some variables here. Okay, so int right equals 0, wrong equals 0, and kinda equals, or near miss, I don't know how you want to put it, near equals 0. Okay, so every time we get an exact match, we will say right plus plus. Every time there's a near miss, near plus plus. Every time it's wrong, plus plus. And since I'm confident this code's working, I'll just comment this out. Okay. Formatting. Oops. Watch this. Dot. Watch this. Dot. It's nice. Dot repeats the last command you did. It's very, very useful. Saves a lot of time. Whatever the last command you did in Vim was, dot does it again. Very useful. And so, now that we got that, we just need to output the count of all this stuff. So, cout correct. And let's see what the formatting is correct. Correct in the wrong position. Cout shift insert. Near miss. And the other one was wrong. Okay, so do that. 6 digits, number seed of 42, 1, 2, 3, 4, 5, 6. Correct is 1, 1 is correct in the wrong position, 4 are wrong. Do it again, 6 digits, 42, 8, 7, 6, 1, 6, 6, all of them are correct. 6 digits, 42, 7, 8, 1, 6, 5, 5. It's got 4 of them correct in the wrong position, 2 of them wrong. Okay, so and if I was doing this for realsies, I'd test this a lot more, but I'm confident this is working. So now that we've got that working, we should probably get around to vetting the guess, because right now, if we do this and we type in a big number, 20 of them were wrong. Can't do that. Okay, so see and guess. Okay, so let's vet guess. All right, so if guess.size is not equal to secret.size, so if the two strings have a different size, then guess I'll die now. Okay. And now we test it. Write a little bit of code, test it. Write a little bit of code, test it. 1, 2, 3, 4, 5, 6. Cool. 642, 20 digits, bad input. Cool. And I would test it some more, but I know it works. And then we need to make sure it doesn't have a squirrel in it, right? So if there's any characters in guess that aren't digits, we need to die also. And so we can do this with a range-based for loop, make it simple. For every character in guess, if that character is not a digit, die. So isDigit is a function that takes one character, and it returns if that is the ASCII code between 0 and 9. So if it's ASCII 0 to ASCII 9, it returns true. And if it's not, it returns false. And so if any of these are not digits, then we die. One line. 642, 1, 2, 3, 4, Q, 6. Bad input. Okay. So, write a little bit of code, test it. Write a little bit of code, test it. Get into that habit. Break it down. Okay. Now, all of this needs to be wrapped into another for loop. And that's the winning. We have to now handle winning. So I started with the innermost part, and I grew out, and I grew out, and I grew out, and it gets bigger and bigger. This to-do can come off. That's now done. So I am now going to wrap this whole thing for int I equals 0, I is less than 20, I plus plus, and I will throw a close bracket there. Now, a lot of you will turn in code like this, but the formatting's wrong. And so what you can do is type equal sign, shift 5. Shift 5 is find the matching parentheses. Shift 5, find the matching parentheses. And equal sign means reformat. So I'm saying equal sign, reformat to the matching curly brace. And it reformats all the lines in that little block of code there. ASCII 0 is value 48. I don't know. It doesn't matter to me. So if you wanted to, Portnoy said he used the ASCII codes. Sure. But this is pretty easy. This is found in the CC type header file, which was handy dandily included for you at the top of the file. So there was kind of an expectation that isDigit would come up. So isDigit handles that if statement for you. Okay, so now 20 times we're going to do this, and there's only 2 things we need to do now. So the first is, if they hit the limit, print nuclear launch detected and quit. All right, just going to delete that comment and just see out nuclear launch detected and quit. And quit. Well, we're at the end of main. It quits. So nothing else needs to be done there. And then the only other thing we need to do is win. And so we need to check, did we print this on the last one? So we have to come over to the README file and see what happens if we win. And if we win, it does in fact print the last set of them. So come over here and it prints a winner. It's you. Okay. So to detect winning, if the number right is equal to the size of the secret, that means we got all of the letters correct, all right in the right place, all is right with the world. And we print out a winner as you, and we quit. So we can quit using exit. Exit quits the program no matter where you are. Technically, since we're in main, we can just return 0. It's the exact same thing. Exit success is the same thing as exiting with error code 0. All of them are the same. So just return 0, I guess. So I think we're done. Let's see how that goes. Oh, that's interesting. GA. Ah, that's neat. Get the ASCII code. That's cool. I didn't know that. Learn something every day. All right, GA. Cool. Get the ASCII code. That's neat. Okay. So we got a warning. This is a sign comparison warning. This is the only warning that you can, maybe ignore. It's probably not a good idea to ignore it. So it is telling us on line 82, character 13, on line 82, character 13 of main.cc, there is a warning. We are comparing a signed and an unsigned character. This is bad because if either of those numbers is negative, it underflows and becomes maxent minus change. So it's a valid warning. You shouldn't have any warnings in your code ever. And so we can fix this right. So we can change the type of right to be an unsigned integer. I'm just going to convert this static cast to an integer. So I'm converting secret size to an integer. I'm converting an unsigned integer to a signed integer. This will break if our secret is ever bigger than 2 billion. But it can't be, because our secret can be a maximum of 6. So, yeah, it's fine. Okay, so we're just going to convert it to an integer. And remember, there's different ways of doing casting, but that's the most official way of doing it. Let's just test it out right now. Please enter random number seed 42. Oh, it's still printing out the right answer for us. And by the way, if you were testing your code without knowing what the secret answer was, that makes your life extra hard. So, yeah, when I was doing my development on it, when I made it originally, I was just printing out the secret answer every time, and then I could, 1, 2, 3, 4, 5, 6, and try it. And I mean, I would hide it when I actually tried playing the game and seeing if I was able to solve it in 20 guesses or less. But basically, when you're doing development, you should always be looking at what the secret password is. Because if you don't know what that is, you're just making it hard on yourself. Is it right? Were 3 wrong? I don't know. So always be scouting all the things. Always be scouting all the things until you're confident that they're right. Okay. So 8, 6, 7, 1, 6, 6. So 4 of them are right. 2 of them are right, but in the wrong position. All right, 8. 7, 6, 1, 6, 6. Correct. A winner is you. And then if we're going to test this with 20 wrong guesses, I'm just gonna okay, nuclear launch detected. Okay, so I think we're done. So let's run the input tester and see how we do. Oh, okay. Looks like we need a period. Funny, because the comment said print nuclear launch detected. So. All right, that was a deliberate. There, nuclear launch detected with a period. Let's see if this does it. There's you. Yeah. Okay. So here, it does have the nuclear launch detected there. So recompile, cheapest bus. Oh no. Okay. So recompile, run the input tester, and we're done. That's it. 10 out of 10. Good solid half hour, 40 minutes of effort, something like that, to do the homework assignment. The estimated time for most of you should be around 6 hours, something like that. And if you weren't able to do it in time, then review this video and just think mentally like, okay, what approach should I take to solving it versus what approach should Kearney take to solving it, and find out where you got stuck. Okay. So the reason, again, the reason I'm doing this is not to flex on you. I'm showing you the approach to solving it, right? Which part do I do first? Which part do I do second? Don't try to do the entire damn thing at once. Even one of my advanced students, right now, I don't want to give a name. I was looking at his code. Let's see if he's in here. Nope. I was looking at his code yesterday, and he had written 100 lines of code without ever compiling it once or testing it once. And there were compilation problems everywhere in it. And I was fixing things here, I was fixing things there, and none of the code was compiling, and he had things in there that he had moved around because it wasn't compiling. And so it was like there were things not even in the right spot anymore because he was just flailing about trying. He's not here good. He was just flailing about because he like made so many mistakes between compiling that he was just guessing. He was like, I'll just try this, I'll try this, I'll delete this, he was deleting important stuff too, and I'll take this and put it up here even though it doesn't do anything, and don't do that. Your code should always compile. Write 3 or 4 lines of code and compile it. If it doesn't compile, you know where the problem is. It's in those 3 lines of code. Like, don't write 100 lines of code because then you're like, what's wrong with it? And the problem is a lot of things were wrong. There was like 6 compilation errors, missing semicolons and like this and that. And compile every few lines, good idea. Yeah, and then test your code. Always, always, always have code that compiles. Always, always, always have code that runs. And build your program like building Legos. Like you just start from the foundation. You start building up, and you build up, and you build up, and you build up. Okay, that's the approach. That's the big thing. Okay, when you do computer science, anytime you're doing a program that's longer than like 4 or 5 lines, like some of the Xi books are just like a couple lines of code. When you're doing anything longer than that, you have to take a very systematic approach to it, and that's something that's especially hard for people that have coded before, right? For what's really funny is that a lot of times, people that have never programmed before think they're at a disadvantage versus people that have been coding since middle school. The people that have been coding since middle school oftentimes have really bad habits, and and trying to just do everything at once is a very common one. And so, like, one of my best students a couple years ago wrote Pokemon from scratch all at once. Did it run? No. Did it compile? No. What was wrong with it? Yes. Help. I don't know where to help you, dude. You got 1,000 lines of code in there and it's not compiling. I don't know, like, you're kind of on your own with this one. I don't know. So he's a good programmer too, but he was just confident and It's like, I'll just write it. Here's the thing. I'm just going to write the whole thing. And it was like, it's like when somebody ties a really complicated knot, like, I challenge you to untie it. No, it's you untie that yourself. You got yourself into this. No, I did help him. But it was a very good teachable moment for why you shouldn't code everything at once. Okay, so that's the big thing for today, how to break down problems. Now, I've got a little bit of slideshows to go over. Let's see here. Call by reference. It's a little tiny slideshow. It's only like a few slides on call by value versus call by reference. We went over this a couple times ago, but it's important. We'll go over it again. Call by value makes a copy, right? So whenever you pass something by value, it duplicates the values in it. It copies the value. So if you change A here, because it's called by value, it does not change X here. It just takes the value of X and passes that in. Call by reference, rather, if you were to pass X in here, because it's called by reference, what gets passed in is not the value, but the memory address. And so the memory address of A, that spot in RAM, if you were to zoom in on a microscope and your block of RAM, somewhere within there's a little label that says that's where X lives. And when you pass X by reference to Squirtle, then A's address is the same. So when you read and write to A, you're reading and writing to X. And that's why it's called call by reference. A memory address, another name for a memory address is a reference. So you either pass the value of X to something, or you pass the address of X to something. That's the difference between call by value and call by reference behind the scenes. If you look at the assembly code, either way, you're passing either a value or you're passing a reference. So pros and cons. It's faster to pass primitives by value. So ints, chars, bools, floats, doubles, all those built-in basic types in C++, they're all faster to pass by value. And by default, you should pass them by value, unless you want them to change. Like here we're changing the values of A and B. That's fine. You can pass them by reference. It's A-OK. It's not a big deal. And it's not that slow. It's just a little bit slower than call by value. But in general, the general rule of thumb is any primitive gets passed by value. And my wallpaper is amazing. Oh, thank you. I didn't make it, but I'll take the compliment anyway. Or was I? There we go. So the general rule of thumb is primitives, which are all the built-in types, get passed by value, and non-primitives, strings are the only non-primitive right now, but we'll be learning vectors and things like that. Those by default should be passed by reference, and oftentimes const reference, so you don't change them if you don't want them to change. Okay. Another benefit of call by reference, and we did not talk about this last time, so it's important to go over, is that people will use call by reference as a way of returning multiple values. So if you want to have a function that returns 5 values, you kind of can in C++, but you kind of can't. In C++, you can only return a single value. You can return int. You can't return 5 ints. I'm going to put an asterisk on that because there's a thing called a tuple, and yeah, that's CSI 41 stuff though. But by default, but even then you're returning one thing. You're returning a single tuple that has 5 ints in it, but the language allows you to return one thing, and one thing only, or nothing. Okay? So in this case, we're returning nothing, but we're writing to both A and B. So this is how you can return 5 things. You just have 5 parameters that are all called by reference, and you write to them. And then you can return 5 different values from a function. It's a very common thing. If you need a function that needs to return multiple things, like a function that is going to find the nearest city and the longest city, longest away city, then it'll typically take call by reference parameters. You pass in the things by reference and it writes to them. Very common. So when you do that, though, it's very important to notate that these are output parameters. Normally when you have a function, a parameter is something that goes into a function. If you're ever going to be writing to it and you're passing data back out through the parameters, it's a really, really good idea to note that on the comment above the line of the function. Because You will surprise people otherwise. They're just passing in X and Y. They don't expect X and Y to change. Like, what the hell just happened here? You know? So it's really important. If you're ever going to be writing to any of your parameters, put a little note. Okay. Speaking of comments, what did you guys think of that last quiz? That was a fun quiz, huh? Did you guys like that last quiz? That was a good time. It was fun for me. It's fun for me to write it. Was it fun for you to take it? Yeah, that was one of my most favorite quizzes ever to write. It's so easy. I gave you the answers too. I gave you the answers. So, yeah, let's see down here, 913 quiz. So let's take the quiz together. So when you saw this for the first time, what does this function do? Void QQ underscore RA underscore SZ. What was your immediate thought on that? What was your thought process when you looked at that? You looked at the answers, takes in two call-by-reference integers and sets them equal to the results of the Hauswolder's transformation. Computes and sets the exponential of two integers with each other. Sets the values of the two parameters equal to the third root of the ecliptic plane. Yeah, we're at swap students, right? So I thought you posted the quiz for the wrong class. Right. So last time we talked about the importance of commenting, right? And there's a lot of people, professional programmers, who write code like this, non-ironically, not for job security. They just write code like this because they're like, isn't it obvious? The QQ stands for there's two real numbers, and RA stands for the return always, and SE is the size. I mean, clearly that's obvious. Like, why are you such a dummy that you don't know what sap underscore TT none means? Come on, dummy, you should get with the program. No, seriously, like, there are people that write code this way, and it's really, really annoying. Because unless you know already what the thing does, it's not impossible, but it's really difficult to figure out what it's doing. And this is why comments are so important. This is why the rule of thumb I gave you guys last time is so important. Always just have, at a minimum, just have a line above a function saying this is what the function's doing. Because if you know what the function's doing, you can oftentimes figure out the code, even if the code's not commented. Right? You can, even if the variable names are obtuse and obscure like this, if you know what the function's doing, a lot of times you can kind of work it out. But legitimately, a lot of people just write code like this, and they're like, all right, there's a bug in there, fix it. It's like, bro, I don't even know what this function's doing. You know? I mean, I don't, like, really? Like, what is it doing? Like, isn't it obvious? No? My brother-in-law gives a workshop on refactoring code. And he gives the, just like fixing bugs in like old code. And he gives them code written in Russian. And so all the comments are in Russian, and there's not many of them. So the variable names are all kind of meaningless because they're Russian, and unless you speak Russian, in which case it might not be that bad. But he has them all fix bugs in a program that is Russian. Nobody has any idea what it's doing. You know, and when I looked at it, I'm like, all right, I'll figure out what this is doing. And it took me like a while. Like, it took me like 10 minutes to figure out. It was like 20 lines of code or so. And I worked through it a line at a time. Like, okay, so if this is this, okay. And I finally kind of figured out what was going on with it after like a good while, like 15 minutes of me staring at it. I finally figured out what he was doing and figured out where the bug was. But he has a whole lecture on like how to fix bugs in code you don't understand. However, I had a stroke. Yeah, that's fair. And so I, however, prefer this. This function swaps two integers without needing a temporary variable. So nice. Right? That's all you need. All the rest of the code could still be living garbage. You know, this is still horribly written code, but with just that one little line saying, this is what this code is doing. This is the purpose of this function. Okay. Got it. You know what I mean? Cool. Swaps two ints. I did leave the previous button open. Click previous. Change that back to swap. Cool. And hit submit, and we get 2 out of 2. I'm kind of curious. Quiz statistics. Let's see how students did on this. It should be 100%. So, some people got none of it right. That's funny. Yeah. Yeah, I gave you the answer. The answer's in it. It's the easiest quiz I've ever given. Yeah. It is. Yeah, my brother does speak a lot on that kind of stuff. Okay. So, yeah, so call by reference can be used to pass values back out as well. That's the other big benefit of it. Okay, so drawback, this is important too. A big drawback of call by reference is that you can't pass numbers to it. Like if you're taking an integer by reference, right, and it's going to try and set a to be 7 and it's going to try and set b to be 42, what would happen if you tried passing in 100 or 900? Like what if it worked? You know what I mean? Like how horrible would that be if it worked and it set the value of 100 to be 7? And every time you used 100 later on, 100 would be 7, which is legal in Fortran. In Fortran, you can change the value of a number to be another number. I don't know why they allow that, but they do, because numbers are just variables. And so if you have a number like 100, you can change the number of 100 to be 7, and then this would be 7. It just seems horrible to me. It just seems like one of the worst design decisions ever for a language, but it's allowed. C++, you can't do it. If you try passing in a numeric literal like this, a numeric literal is like a hard-coded number in your code. And by the way, don't have hard-coded numbers. That's something I should have mentioned earlier when I was on the server. Become Rob Thomas. Let's see, hack the mainframe, then main.cc. What you should do rather than hard coding, because in my code I just had 20 here, right? I had 20 in the code I just wrote for you. What you should use instead is a constant. Anytime you have a hard-coded number like that, that is something called a magic number. And magic numbers are bad, okay? They're bad. Don't have them. The only numbers you can have in your code that that's a magic number, like you should have a constant saying minimum length 1, maximum length equals 2. Don't ever have magic numbers in your code. 0 is okay. Everybody knows 0. You don't have to explain 0. You don't have to explain that. You're initializing it to 0. It's fine. 0 you don't need. But for anything like 20 or 17 or something like that, what the hell does 20 mean? Where does that come from? You know what I mean? So make a constant, and then it's got English. Remember, programming is for people. You know, software like this is for humans to read and for humans to write. It's not for computers. The computer does not care if you have a 20 there or you made it a constant. It's going to work the same way. But by doing this, you've put an English word where there was a mystery before. Where did 20 come from? I don't know. You know? Who set that? I don't know. What does it mean? I don't know. If you got a million lines of code, you just got a 20 sitting there. You're like, eh. You know? And so with this, you're like, okay, it's the maximum number of guesses allowed. Okay, cool. Got it. Okay? And this 6 up here is also a magic number. That should also be changed. We should have like const int min size equals 1, max size equals 6. By the way, we all caps constants. Usually that's not universally true, but it's like 80% true. Any constant that doesn't change, it's very commonly in all caps like that. So you know that it's a constant and it doesn't change. So that's a better way of writing that code. Magic numbers are bad. Okay? They're like a turd left on the sidewalk. You walk up to and you're like, why are you there? Why are you sitting there? I don't know why you're there. What are you doing there? I don't even know. Okay? So get rid of all of your magic numbers. It's just general, like, good advice. Okay? So, yeah, so these are magic numbers. Get rid of them. Okay. But this code doesn't compile, right? Because you're passing in a number. You can't change a number. So instead, you have to pass in a variable. Okay. So call by reference only takes variables. It can't take numbers. If it was call by value, you could do this because call by value copies the value. Call by reference takes the memory address of the variable. There is no memory address to these. They're not variables. They don't have a memory address. So you can't pass them in. Okay. Which leads us to our final topic for today. And I'm going to go probably about 7 minutes over. So if you need to leave, that's fine. Just watch the last 7 minutes of this at your leisure. But we're going to go over an important bit of terminology, bit of vocabulary in C++. So when you type code like this, like average is equal to x plus y plus z divided by 3, what's happening behind the scenes is that it loads from the spot in RAM where x is found, it loads from the spot in RAM where y is found, it loads from the spot in RAM where z is found. Simplifying a bit because the optimizer oftentimes will eliminate loads when it doesn't have to, but that's the general idea. So there's a memory address for x, there's a memory address for y, there's a memory address for z. It goes to that spot in RAM, pulls the value of x out, which is, I guess, 0, pulls the value of y out, which is 3, pulls the value of z out of RAM, 10, adds them together, and it uses the types to figure out what kind of arithmetic it should do. That's an int, that's an int, that's a float. If you add an int plus an int, you get an int. 0 plus 3 is 3. Cool. Got an int. Int plus a float, you get a float. 3 plus 10, 13 as a float. 13 divided by 3, float divided by int, you get a float. So it computes that, gets 4.3, and then it stores the value of 4.3 into the memory address of average. And I've just made up some imaginary memory addresses here. These aren't, don't stare too closely at them. They're just random numbers I typed on the keyboard. Okay, so in C++, every variable is 4 things. It's a name, it's a type. The type is what kind of values it can hold. Can it hold a word, like a string? Can it hold a single character, like a char? Can it hold true or false, like a bool? Maybe I should make this 10.0, something like that. It's a float, it can hold decimals. And so every variable is 4 things. It's a name, it's a type, it's some spot in RAM, and that's normally hidden from the user, because we usually don't care. We usually just don't care what spot in RAM it is. You can print it like we did last time. If you see out ampersand x, then that prints the memory address of x. If you're curious, like, you're usually not, but if you want, it's available, if you care about that kind of stuff. But usually the memory address is we just let the compiler handle that. Okay, and then there's the value of the variable, which is what we care very much about, right? This is 0, that's 3, that's 10. We're adding them together, dividing by 3. What do we got? Bippity boppity boo, 4.3. Okay, so a variable is these 4 things. Okay, now think about this. You can set x equal to y plus z plus 7. Can you set 7 equal to x? Does that make any sense? When you do an assignment operation, what you're saying is write to this spot in RAM, whatever that spot in RAM is, 9876634. Write to that spot in RAM, whatever value you load from here, add 7 to it, and then you're going to write to that spot in RAM the sum of these values. Does this make any sense? 7 is equal to x. This isn't algebra. This isn't algebra equality. In the previous class, the student was like, wait, so they're not symmetrical? They're not reflexive? No, because this isn't algebra. This is assignment. This is why, in a lot of programming languages, maybe a lot. Some programming languages, they do this. Like, they'll write assignment like that. To make it clear, you're setting a value, you're not doing algebra. Okay. In C++, equality is 2 equals. Comparison is 2 equals. Assignment, setting a value, is 1 equals. Okay? It makes no sense. That's correct. 7's not a variable. It's not Fortran. You cannot set the value of 7 to be x. It doesn't make any sense. What's the memory address of 7? It's a Platonic number. It doesn't even exist in reality. It doesn't even make any sense. And so in C++, there's a very, very important bit of terminology here called an L value and an R value. An L value is something that can appear on the left-hand side of an equal statement, not equality assignment statement. So x is an L value because you can write to it. It's got a memory address. You can write to it. You can put it on the left side of an equal sign. It's an L value. It goes on the left side. R values are things that cannot go on the left side. Now, x could appear on the right side. That doesn't make it an R value, a right side value. A right side value is things that are not L values. So 7 is an R value. It cannot go on the left side here. This doesn't even make sense. Okay? 7's an R value. And so if you, and the reason why this terminology is important is because your compiler is gonna tell you. All right. So if we have, if we try passing in 100 to this function takes call by reference, right? there is no memory address of 100. And what it's going to say is G++ main.cc. What it's going to say is cannot bind Lvalue. Look, there's our terminology. Cannot bind Lvalue reference of type int reference to an R value. 100 is an R value. 100 is an R value. R values can only appear on the right side of an equal sign. R values cannot be passed to a call-by-reference parameter. Call-by-reference parameters only take L values, things that can appear on the left side, i.e. regular variables. Okay. So that's why this terminology is important, is because you're going to see these in error messages, and you need to know what they are, right? So yeah, 7 equals x. Let's try that. Int x equals 0. 7 equals x. Error. L value required as left operand of assignment. You have to have an L value on the left side. 7's not an L value. 7 can only appear on the right hand side, so it's an R value. Okay. The claim gives you maybe more readable error messages. Expressions not assignable. But what about this? Do you guys think this is legal? Int x equals x. Creating a variable named x and we're initializing it with the value of x. How many of you are waiting for the red arrows there? Is it legal? Can you initialize a variable to itself? It's legal. I don't know what it is. I wouldn't ever write code that way, but warning. Yeah. Warning. Fair enough. Yeah, you're initializing it to itself. Yeah, don't do that. Don't do that. It's bad. It's bad code. Okay. Okay. So last slide, and then we're done for the day. Let's say we got a function called foo, and foo just returns 42. Okay. Can you do this? Does this make any sense? Can you say foo is equal to x plus y plus z? Does that make any sense whatsoever? What do you think? Nope. The return value of a function is most 100%ly an R value, unless you're returning something like a reference. If you're returning like a reference, then it could in fact be an L value, but this thing is most definitely an R value. The return value of a function like this is an R value. Okay, so no, you cannot set this. This doesn't even make sense to me. You could set x equal to foo, but you can't set foo equal to x. Doesn't make any sense. It's like, imagine you replace that with the number 42, and you can see why that doesn't make any sense. Okay, what about x plus y equals z? Does that make any sense? There's probably some Python programmers here who, yeah, of course, that makes sense. Of course. What do you think? In algebra, not here. Yeah, that's a good way of putting it. Yeah, no, because anytime you add two variables together, you get like a temporary R value. And so you cannot say x plus y equals z, because it creates a temporary R value. R values can't be on the left side of an assignment. Compilation error. And in fact, it'll probably say that you got an R value there, buddy. I don't know what you want me. I don't know what you want me. So this is 100% doesn't make sense. I mean, think about it. Like, what are you trying to write to x? Are you trying to write to y? I don't even know. What? So anytime you have a temporary like that, it's an R value. Okay. You can say z is equal to x plus y, because x plus y is an R value. It can appear on the right side of an equal sign. That's why it's called an R value. But R values cannot appear on the left side. Okay, here we got a constant. Constant max equals 10. And we're trying to set max equals equal to x. Is that okay? Can you change the value of a constant? Simple question. Nope. And that's wrong just because it's a constant, you know. You can't change constants. Constants are read-only. So whether or not it actually has an address in memory is a good question. And a lot of times it just won't exist at all. Like, it'll just almost do like a textual substitution. Anytime max goals appears, it puts 10 there, but constants can exist in memory, so it's more complicated than that. But this doesn't work because it's a constant. Okay? So this one, void bar int reference x is equal to 42. So we got a function that takes call by reference. Can we pass 100 to a call by reference parameter? What do you guys think? Can you pass a constant or a numeric literal? That's what it's called. There's a numeric literal. Numeric literal is any hard-coded number in your code, which again you shouldn't do except for 0, maybe 1. Magic number. Can you pass it? What do you guys think? Nah. It's an R-value. R-values cannot be passed by reference. So I just showed you that on the server. Okay. So if you have a call by reference function, it can only take an L value. And that's it. So that's it for today. Call by value, call by reference, really important stuff. But we'll pick it up next time with strings. And you don't have any homework right now as far as programming assignments go. I did put up the new Zybooks. We're going to be traveling backwards in time on Zybooks. We're going to be doing chapter 2, because that does go over some of the string stuff that we're about to be talking about on Friday. So trying to get that done as much as possible before Friday if you want, or if not, I'm not going to judge. It's fine. You do have the loops extra credit, or was that due already? Not a lot of people did it. It's kind of weird. So that was due already. Yeah. Like I think almost nobody did it. So if you want more extra credit, you guys are gonna have to do the extra credit. It does take me a huge amount of time to put them up, like a whole 30 seconds or so. So I don't want to waste my time. I'm kidding. No, I give lots of extra credit. The next extra credit is going to be Friday. There's a talk at Fresno State by a engineer who switched engineering degrees. I don't really know what the point of it is, but the dean of our college sent it to me and said it would be great if my students could go to it. So if you want to go to it and write up an essay on what they said, and I will give you extra credit points for doing that. So if you potatoed on Hack the Mainframe and you haven't used your last chance yet, I just solved it for you. Seems like an easy last chance opportunity. I don't know. Don't turn in my code. That's kind of lame. Try solving it yourself, right? So if you didn't do Hack the Planet or whatever, Hack the Mainframe, do it yourself. You can look at my code and use it as a guide, but please don't just copy it. You know, it's kind of, I feel like you're not learning very much if you do that. Is it on Zoom? I don't know. I don't know any details about it. Some of them would freeze and go into submit mode. You know, helps that issue. I don't know. So, yeah, maybe if an infinite loop or something. I don't know. So yeah, extra credit on Friday for that. And otherwise, no homework right now. Just the next Zybooks. And that'll be due a week from today. 2 o'clock. Okay. Thanks, everyone. And I will see you on Friday for lab time. Peace out.